In this video, we're going to find the determinant of a 3x3 matrix, and I've kind of set a 3x3 matrix up here like you're going to see it used with vectors. So what's going to be happening is you're going to be given two vectors, like this one's three-dimensional here and this one's three-dimensional, and the x, the y, and the z component are going to go here for the first one, and then the x, the y, and the z component are going to go here for the second one. And then you're going to be asked to find this other vector here that's perpendicular to both. And it turns out that if you can find the determinant of this 3x3 matrix, you will find that vector that's perpendicular to the other two at the same time. So I'm going to show you a couple different methods. We'll use method 1 here. And I'm not sure exactly what to call this method, but what you essentially are going to do is you're going to set up a smaller version so that you can find some 2x2 determinants, and then that will lead you to the same conclusion that the other method will lead you to as well. So this is just a method to find a determinant. So what you're going to do is you're going to take a look at the upper left hand position, which is an I, and then what you need to do is you need to block off the row and also the column that I is in, and you're going to be left with a 2x2. And you're simply going to write this 2x2 down just on the right hand side there. So it looks like -4, 8, and -7 will be what we need. So we'll do this: -4, 6, 8, and -7. And then we're going to write that I down right here on the side. Okay, whichever letter you're looking at here in the top row, block off that row and column, you'll be left with a smaller 2x2. This first one is always positive. I'll put a plus sign just to emphasize that. The next one is negative, and then the one after will be positive. So you need to make sure that your signs differ for each single matrix that you do right. So we're going to do something similar with J. And for J, we'll try and do the same thing. Here's J, so we don't want this top row, and we don't want the middle column either. And so we're left with another 2x2 matrix. So this one's 1, 6, 3, -7. And then we're going to have that variable that we were looking at before here, or that unit vector I should say, that position in the matrix. So that's J. Remember, positive, negative, positive. And then this one's going to be K. If we block off the row and the column for K, you're left with 1, -4, 3, 8. So essentially what you're going to wind up doing is you're always going to be getting rid of this top row here, and then whichever column that the letter is in, you'll get rid of that and you'll be left with a 2x2. Then what we need to do is find the determinant of these 2x2s. So if you remember back to your work with matrices, or maybe this is the first time for you, so I'll just show you how to do it. So we've got a -4 times -7, and then we're gonna subtract 8 times 6 here. And so it's like the upper left corner times the lower right minus the upper right times the lower left in any order, 8, 6, 6, 8, whichever goes here, but there needs to be definitely a minus sign in the middle there. The next one is going to be 1 times -7, and then minus 3 times 6. And there'll be a J there. And then also for the next one, it's going to be plus here, and then you're going to have 1 times -7 minus 3 times -4, and there'll be a K on the outside there. So if we knock this out here, this one's going to be 28 minus 48 with an I, minus sign, this is -7 minus 18 with a J, and then the next one will be -7, and then we're going to have plus 12 here, and that's going to be for K. Alright, and you know what? No, I think I did write that down wrong. I'm sorry. So -1, -4, 3, and this should be an 8. My fault there. So actually we're going to make that an 8, and this one should be an 8 as well. So you have to back up a little bit, but often a good idea to kind of recheck these as you're figuring out right now. It's easy to make a mistake. And if you look on the top row, we see a 1 here only once, or excuse me, 1 here in 2 of them, and then 6 here in 2 of them, -4 in 2 of them. So I had -7, -7, and -7. You're not going to see all 3 having the same value unless it's the same value up here. So on the next one we've got 28 minus 48, which is -20, and then our vector I. And we've got minus -25, which is plus 25, vector J. And then the next one is 8 plus 12, which is 20, and vector K. So you could also write this in its vector ordered pair form, and that would be -20, 25, 20. And if you graph these things, this vector ordered pair here, this vector would be perpendicular to each one of these at the same time. Method 2, we'll have to sneak this up just a little bit. So for method 2, you're going to wind up with the exact same answer, but just a little bit different how to get there. And so you're going to write your matrix out here. I, J, and K will use the same one. 1, -4, 6, and then 3, 8, and -7. And this time what we're going to do is we're going to recopy I and J down here, both of those columns. So that'll be 1 and 3, and then -4 and 8. And so to find the determinant of this, what you will do is you will look in the diagonal fashion. So for I, you're going to go right here and you're just going to multiply all those together. So this is going to be 28I, and then for J it's going to be J times 6 times 3, which is 18J, and then K is going to be 8K. And then what we need to do is go the other direction. So anything that goes from the left slanted to the right is going to be positive, and then we need to do the opposite of the slants to the left. So here's what's going to happen. We're going to have the I here, and that's going to be 8 times 6, which is 48. And then we've got a J here, so J is going to be -7 times 1, so that's -7J. And then K will be -12, 3 times -4 and K. And the secret here is that we have to subtract all of these from the ones on the top. So anytime you're going upper left to bottom right, you'll leave those values. You don't have to do anything with them. There can be negatives in here, of course, but whatever the values are, you leave them. And then we're going to subtract going from right to left, so kind of reverse like how you would read. And if we do that, what we'll wind up with here is 28 minus 48, which is -20I. And then this one's going to be 18 minus -7. That's a gotcha, so heads up here, 18 minus -7, you have to actually add those together. So that's 25J, and then 8 minus -12 would be 8 plus 12, which would be 20K. So if you take a look at either method, this method 1 uses some smaller 2x2s, and you get to find the determinant there. You got to remember your plus, minus, and plus. We wind up with -20I, 25J, and 20K. This method, we end up with the same thing. You have to extend it out a little bit, and then you're going to go diagonally across, and then everything that you go from right to left, you need to make sure to subtract that. So this is the gotcha part, kind of right here. Most often made student mistake is to take 28 minus 48, and then do 18, and then just do -7J. After you do the original one first, these other two can kind of get lost, so just be careful.